let's go on. And then, yeah, there are so many more numbers you could look at, but let's not do that. But let's go to the fourth slide here, because this is the most recent one. Because now recently we have also tried to find out if it would be possible to, in a consistent and coherent way, look at the resource inputs in this way and trying to, assign some externality value to the resources that we take into the system. And so the idea is that in order to have consistency, we would have the same number here and there. So it's obviously very different. And it can have to do with the number of factors that are included in the various methods that are underlying the number that actually comes out here, but obviously it shows that these methods are not so far researched or developed that we can actually state in detail why there is a difference. I mean, I know in principle what is the difference, but I think if I may guess something, the surplus cost is a little bit related to the XLG concept, because it actually has a kind of marginal approach to how much would the next amount of resource cost to extract when we have already emptied the available current resources. But anyway, it's an ongoing work, so that's what I wanted to indicate to you, and the work is underway. Okay. Next, please. Just one application example as finalization here that I will show you, where we have actually applied this kind of monitorization of environmental impacts to assess. Next, please. Yeah. Once again, we did actually a study a few years ago on strategies for recovery of plastic packaging waste in Sweden on behalf of this company that's responsible for the collection of plastic waste, and the Swedish EPA. Next, please. Yeah, let's go to the next again. This one. So we did, let's say, a market analysis and an environmental analysis of the current system. So what is contained in the system? Well, we have the collection, sorting in 2 steps actually, and then the final management, which is either energy recovery, or it could also be then recycling into new products, obviously. But that comes in down here, because then we substitute virgin material. Let's see now, so I don't mix up things, or to give you the right information here. Basically, the actual system in place, which meant that plastic packaging waste was collected from households and from collection points, and the cost for doing that in financial cost for the operators are these yellow and orange and more or less red bars. So the actual collection is here, the mechanical recycling processes are here. So coming out from this mechanical recycling is actually raw material that can be used to make new products. Some of the collected material was sorted out, and it was sent to regular municipal solid waste incinerators and was recovered for its energy. So that's the benefit you get here from that, or the positive economic output. But it's in fact a cost, because they had to pay the municipal solid waste incinerators to get rid of this residual. Then the managing organization has an overhead cost, so that's also included here. Then the comparative alternative that we investigated was, okay, so let's assume that we just quit doing this collection because we think what they actually thought was the costs are too high. So what would happen if we just quit doing this? Okay? So all the plastic packaging waste will go with the residual waste from households. But still, this residual waste is collected, so there is a cost connected to that. So basically, the costs connected with the incineration system is going that way, whereas the cost associated with the recycling system is going that way. And again, this increased amount of waste would have to be paid for to get rid of for the municipal solid waste incinerators. And there is also some overhead in the organizations dealing with that. So it turned out that if you compare these bars, the overall waste management cost balance is quite high, meaning that in fact the separate sorting is much more expensive than letting everything go with the residual waste, as this system was operated at the time, I have to say. But then there were some benefits coming in. In fact, reducing this cost, or that could be calculated as reducing these costs. So, as I told you, there was some kind of material coming out here. So this has a market value, and that's represented here, because if you incinerate it, you don't have this market value anymore, so that's why it comes to the negative side here. You also have better environmental performance in this system than these systems provide. So that gives you also some kind of green bar here, which is the environment, the cost balance. So the total result...
what is included in this environmental cost?
This is basically the LCA for the two systems and comparing the outcomes in monetary terms. We used, in this case, the external valuation factors to calculate finally the environmental externalities associated with the environmental impacts. So we assigned to each emission a certain monetary value based on the external system. So by doing this, we found out that, okay, there is still also higher cost for the current system than it would be for this alternative system. Now you may ask yourself what happened in the end. Well, the obvious, let's say, statement coming from this result is that we should go for this alternative system. But the alternative answer is that, okay, why don't you take a look at these costs and see how you can reduce them? Because they are somehow ridiculously high. And that is basically what happened. So it's not always the obvious answer coming out of a bar chart like this that is actually guiding your action later on. Okay? Yeah. And my wrap-up is basically to say thank you for listening to my presentation, and I hope you enjoy the conference very much in the next few days. Thank you.
We'll take a break and we'll go for lunch, but let's first arrange for the meeting today and tomorrow. There are some
Yes.
people that are not here. Let's look at
As we said, we have some dropouts, people that have not showed up, and it means, for some reason, quite a few of the presentations that were planned for this afternoon have no presenters yet, so we should have a short review of the situation and see how we can rearrange a little bit to make it better.
Okay. For this afternoon, Ioannidis is here. Dimitra, where is Dimitra? Okay. And the rest of the people are gone. They're not here. So we can move some people from the session on Tuesday. So we can finish the conference tomorrow night, tomorrow afternoon. On Tuesday we have Dietrich Smith here, Dietrich, he was coming today, so we can move him. But on tomorrow we have Thomas.
Yeah, Matthias, you could give your presentation this afternoon instead.
Matthias can do it today. So instead of 4:30, we can start at.
Start 4:30 and then we fill up. Maybe?
4:30 is 12. It's forgot.
Ah, okay.
So we start at 5:30 and then break later for coffee. So 5:30 we'll start with Ioannidis. And then we have Matthias, who will be leaving from tomorrow morning. It will be at 6. And then Smith is there also.
Maybe we could ask also Heinz.
Yeah.
Would you be prepared to give your talk this afternoon?
Well, if I have to.
Or you have to prepare during the night maybe?
Well, I will prepare it during the lunch break.
Okay, when are you assigned? So, okay,
So I can change it during the lunch break. It's almost finished.
okay, so we make 3 presentations for today, 5:30, 6 and 6:30.
Just tell me when I should do the presentation.
6:30.
6:30. 6?
So Matthias, you're at 6 o'clock.
Well, there is kind of difficult. According to my schedule here, the last talk is 5:45. So 5:45. So maybe we are not talking